All right, so y'all, like I said, we're going to knock out the last half of it, and then we'll go back into the beginning of it and sort of go through some of the trickier ones in that. So it says the length of pregnancy terms for a particular species of mammal are nearly normally distributed about a mean pregnancy length with a standard deviation of 15 days. About what percentage of births would be expected to occur within 15 days of the mean pregnancy length? So I'm going to get a paper to draw that on. So remember, my standard deviation was 15 days. So let me write that real quick. Standard deviation, 15 days. All right, so this goes back to when we was drawing them curves and we was dividing it up into the standard deviations. So let me draw my normal curve for you. And remember, right in the center of that curve was what we called our mean. Now, we're not worried about what the mean is because they're going to use standard deviations for this problem. So to the left and to the right, these values represent one standard deviation. You can go left, one standard deviation, and right, one standard deviation. So that would be +1 and -1 going to the left. So -1 standard deviation to the left, +1 to the right. Now, we learned, we had charts that said if your data points lie within one standard deviation of your mean, then that was equal to 68% of your data. So 68% of the data is going to fall within -15 from that mean or +15. Then we said out here, this was 2 standard deviations to the right. This was 2 standard deviations from the left. So between 2 standard deviations from the left and right, we said that 95% of our data would be in that area. Right out here was -3 standard deviations, and then +3 standard deviations. So data that falls within 3 standard deviations on either side from the mean, that would cover 99.7% of our data would fall within 3 standard deviations of our mean. So their question, remember, was what percentage of births would be expected to occur within 15 days? So if this is your mean and they're giving us 15 days is equal to 1 standard deviation, that means you could either be 15 higher or 15 lower. So now we look at how much of our data falls within that area. Well, we said up here from 1 standard deviation to a positive standard deviation was 68% of our data. So the answer there would be 68%. Now, had I said what percent would be within 30 days? Well, if a standard deviation is 15 days, 30 days would be equal to 2 standard deviations. So if we was going 30 days, we would go out, well, how much data is within 2 standard deviations? And that would have been 95%, okay? So that's how you sort of use that. Figure out how far is the standard deviation that they're going to give you, and then figure out your little curves. It's always going to be 68%, 1 standard deviation, 95 within 2, and then 99.7 within 3. So y'all, you would come in here, put in 68 and be done. So that's a good picture to have a chart of, is that little curve I just drew, okay? All right, so this one says the time it took Claudia to drive to work is normally distributed with a mean of 47 minutes and a standard deviation of 5 minutes. So let's see. We're going to draw our curve like I just did. But y'all, this time they're giving me the data. They're saying, hey, right here in the middle, your mean is going to be 47 minutes. So we got 47 minutes right in the middle. And then it says our standard deviation is 5 minutes. So our standard deviation is 5 minutes. So that means over here at +1 standard deviation, over here would be -1 standard deviation. Now remember, this is adding 5 and subtracting 5. So the actual value of 1 standard deviation would be 47 + 5, which would be 52. Over here on this side, if you took away the 5, 47 - 5 would be 42. Right, but let's see. They wanted to know 57 minutes. So I'm going to have to go out another standard deviation to both sides. This would be 2 standard deviations to the right. That would be 2 to the left. So we're at 52 at 1 standard deviation. We add 5 to that, we'll be at 57. If we subtracted 5, we would be at 37. So now this said, what percentage of the time will it take her less than 57 minutes to drive? So y'all on this one, we come over here to where 57 is, and we need to figure out our percentage of this graph. Okay, so to do that, we know this part's filled, this part's filled, but also since this is to the left, we would fill that. So we got to figure out how much of this is not shaded. Okay, so for 3 standard deviations to be shaded on this, we said was what, 99%? Because what you got to, well, what we got to do is figure out how much is in this left tail over here. So out to 2 standard deviations on our chart, remember this was what, 68% in the middle, 95% for 2 standard deviations, which is what we got. So here's the trick. We got to figure out how much is in this end, because remember, that's less than that 57, okay? So you got 95 for these 2 sections. Well, 100 - 95 leaves you 5%. These 2 tails divide that 5% up. So let's see, 5 divided by 2 is what, 2.5? So y'all remember the tails add 2.5 each. Okay, 95 within 2. These are the other 5. So we got to shade this 2.5 on the left. Anything on your test that's less than that value, okay? So we would add that tail to our 95% and get 97.5%. So that would be our D. Now, had we not used that tail, then it would have been 95%, okay? So when they say less than 57, you're only looking for all the data that's less than your standard deviation, okay? Okay, so I sort of wrote down here a little bit, but here's the gist of this question. The odds on your bet are 5 to 6. So we got 5 to 6 odds. We're going to bet $24. how much will we gain? Now they're going to give you what you bet back, but we're looking at for how much you're going to gain for this. So what 5 to 6 means, if you win $5 for every $6 that you bet. So your win is the top first number. The betting amount is the second number. So we got $24. We divide that by how much each bet is. So if we bet 24 and we divide by 6 bets, that's going to give me $4 that I win, okay? So now, if you win $4 per bet, I mean, if that equals 4 bets, you win 5. So 4 times that 5 would give us $20 that we gain on that bet. Okay, so see how many bets your money is out of the money you're betting with. How many bets did that give you? And then remember that top number, 5, is what you win for that bet, okay? All right, so that would be $20. All right, you got a multiple choice test. Each question has 6 possible answers. If you make a random guess on the first question, what is the probability that you got it correct? Well, you're making one guess, right? So your number of guesses is 1. The total number of choices you had was 6. So your probability would be a 1 out of 6 chance to randomly pick that correct answer, which means you got a 5 out of 6 chance of getting the wrong answer. Okay. All right, y'all, here we go. Look at this. The bag contains 6 red marbles, 3 blue marbles, 7 green marbles. If a marble is randomly selected, what is the probability that it is blue? So remember, for that one, I have to take how many blue marbles I have, which is 3. So this is the blue marbles over the total amount of marbles. Well, I got 6 plus 3 is 9. 9 plus 7 is 16 total marbles. Okay, so 3 out of 16 will not reduce down, so we would go with choice C. But y'all watch out. Some of those times, if the fraction reduces, then you got to reduce it for their answer, okay? All right, so I'm going to move that up a little bit. So 39, the probability that Lewis will pass his statistics test is 68. Find the probability that he will fail his statistics test. Well, the probability that he'll fail, remember we did all this, P not A equals 100 minus P of A. I mean, not 100, that'd be 1.0. They've already converted it into decimals. So since they converted it into decimals, it's going to be 1 minus the probability of passing, okay? So that probability they gave us was 68.68. So we would do 1 minus 0.68. And that would give us a 0.32. So that would be our D. Now, if they'd have said percent-wise, like 68%, then we would have subtracted that from 100. But since they gave it to us in decimal form, we use 1. Okay?
Can you move that page back up?
Other way?
Yeah. Thank you. Okay, can you move it back now?
Okay.
Thank you.
All righty, y'all. So number 40. Decide which method, theoretical, relative frequency, or subjective, is appropriate and compute or estimate the following probability. So number 40, an experiment consists of drawing one card from a 52 card deck. What is the probability of drawing a red 7? So for this, since I'm just going to figure it out by hand and do that, that is what we would call our theoretical. Remember, relative frequency, that's when you actually did the experiments and you tried to draw a red card. And then subjective was based on your prior knowledge, okay? So now the probability of drawing a red 7. So the one thing I do know, there are 52 cards in a playing deck. So what I got to figure out now, so this is total cards. They're talking about a red 7. So we got to figure out how many red 7s is in that playing deck. So what, we got 2 red suits and 2 black suits. So there would be what, 2 red 7s. So technically our probability is 2 out of 52, but guess what? That fraction reduces. So those were red 7s. So 2 over 52 will reduce, and y'all watch this. If you don't like reducing fractions, use the calculator. 2 divided by 52 gives you a decimal, but if you hit the math button and you hit enter and then enter, it'll give you 1 over 26, which is the reduced fraction. Now, how they got that? They basically divided both of these numbers by 2. Since they divided by 2, 2 divided by 2 was 1, 52 divided by 2 was 26. All right, state which method again should be used to answer this question. What is the probability of being dealt a pair of queens in a 5-card hand? So a pair of queens in a 5-card hand. All right, so we're looking at how many queens we got out of how many cards we're using. So let's see what they're saying here. Oh, they don't want us to figure this one out. They just want us to tell how we would do it. So we would use the theoretical again. And then basically counting all the possible hands where we could get 2 queens. So where was that? That would be the first one. Okay. So counting all the possible hands with a pair of queens. So that could be a full house, 2 of a kind, 2 pair, things like that. Okay. So look at all the possible hands, and then you figure out how many of them had 2 queens. Let's see, 42. Pizza House offers 2 different salads, 2 kinds of pizza, and 5 different desserts. So how many different 3-course meals can be ordered? So when they give you a list like this, this is where you multiplied all them numbers together. So you had 2 different salads times 2 different pizzas. So right there, just using that, you get 4 different meal combinations, right? You can have chef salad, pepperoni, chef salad or sausage. You can have Caesar salad, pepperoni, Caesar salad, sausage. So that's what they're talking about. Now, we also on this one had 5 kinds of desserts. So multiply those 3 numbers together. So 2 times 2 is 4. 4 times 5 is 20. So you would have 20 different types of meals you could order. So now we're getting into some of the stuff y'all just had on my chapter 8 and 9 test. This one's talking about a price of a computer decreasing at 11%. State whether that's linear, exponential, and then they're wanting us to find the cost. Well, we just got, if you haven't done 8 and 9 tests, you've at least went to our lesson the other day. And we said if it had percent in it, it was going to be exponential. So exponential, unfortunately, was the harder of the 2 to figure out. So they're talking about 3 years. So I'm going to do year 1, year 2, and year 3. Now remember, this one's decreasing, so I'm going to subtract that 11% each time. So I start with $100 times 11%. Remember, make that a decimal, so that would be a 0.11. So let's see what 11% of 100 gives us. That gives us $11. So now it's decreasing, so we subtract that $11 from our 100 that we started with. So that means at the end of the first year, it's at $89. So now year 2, we start with the $89. Figure out 11% of that 89. So 0.11 times 89. That gives us 979. So now for the second year, I'm going to take the amount it started the second year, which was 89, and subtract 979. So now it's down to 79.21. So after 2 years, it done lost a little value. So now we start the last year with that 79.21. Figure out 11% of that. So 0.11 times 79.21 gives me 8.7. I'm just going to go 2 decimal places now. So 7131 around to a 71. Now, take the beginning amount on the third year, 79.21, subtract your 871 that it lost during the year, and I'm coming up with 70.5. Now, notice on their blank, they say round to the nearest cents. So if we want that to look like cents, we would just add another 0. So that would be $70.50. But y'all, here's the thing. If you just put 70.5, I don't think you'll mark that wrong, because I did it on one of the reviews. So you should be good to go as long as you get that 70.5 part of it, okay? So see, this is now that new material, because y'all was doing exponential linear for that test you got this week. All right, y'all, so let me see, on to number, what, 44. Hey, also 44 here says the population of a town is increasing by 629 people per year. State whether that's linear or exponential. If it's 1,300 a day, what would the population be in 5 years? So that's not going up by 1%. It's going up by 629 people every year. So that one is linear. So now to figure out linear, I get the starting amount and then add that to how many people it's going up per year times the number of years. So let's see, we're starting with 1,300. We're going to add that to 629 people per year. So that's 629 people per year times 5 years. So I'm going to punch that on my calculator. 1,300 plus 629 per year times 5 years. That will give us 4,445. So that population, woo, that went up pretty good. 1,300, no, they went up quite a bit, almost tripled that population. Okay. Oh, 45 is another one. Look here. During the worst periods of hyperinflation in a country, the price of food increased at a rate of 30% per month. Say whether that's linear or exponential. And then if our food was 150 in 1 month, what did it become 3 months later? So I'm going to tell you, it's going to be bad because 30% is quite a bit for inflation. But it does talk about percent, so this one is definitely exponential. So now, what was monthly food after 3 months? So I'm going to do month 1, month 2, and month 3. So the first month it started at, what did we say, $150. We're going to multiply that by 30%, which is 0.30. Or you could just use a 0.3 for that and it would work. Okay. So here we go. 150 times 0.30 gives me 45. So since this one is inflation, we're adding the 45 to the 150. So that plus 150 gives me 195 at the end of 1 month with hyperinflation. So then we start month 2 with the 195, and we figure 30% of that. So 195 times 0.30 gives me 58.5. So at the end of the month 2, we add that 58.5 plus our 195 that we started that month at. And our groceries are now up to 253.5. So start month 3 at 253.5. Figure out 30% of that. That's going to be 76.05. So my final step, add that 76.05 to our 253.5. So after 3 months, our food bill went up to $329.55. Woo, that'd be rough, y'all. Now, look here. This one says round to the nearest dollar. So when they say round to the nearest dollar, they don't want no cents or nothing after the decimal. So that's a 9 that's followed by a 5. So since that's a 5 behind that 9, I'm going to make this one $330. Okay, so if you got money and you're rounding to the nearest dollar, anything that's 50 cents or above rounds it up. 49 cents and below would round you down or leave it the same, okay? So check this out. And this was just seeing if you could read a graph. Crafty Bill's Cool Car Sales opened as a used car sales lot in 2001. So that's right here when he opened. The graph shows the number of cars sold as a function of time. So time is years. And then over here is the number of cars sold. What is the approximate number of cars sold in 2003? So 2003 is this line going up over here in between the 02 and the 04. So that's 03. So we're looking at this point right here. So if we take that point and go left, it ain't quite to the next line. So that would be the 900 line. It looks like it's in between the 800 line and the 900 line. So I'm going to call that one 850. So follow the years and get your year. Then go straight up to that graph and find what point is highlighted. And then remember, this left side is going by 100s, but they're only labeling the even hundreds. Okay. So not too bad, yet. Just wanted you to play with that like y'all did on that homework. All right, so let's see what's next. 47. Now, y'all just had this on your test. If you did test 8 and 9 yet, you've done this problem. And it's always the same answer. But use the graph to describe the function in words. Well, it looks like it's going up in years from 1980. Over here, it's not quite to the line, so it's about, looks like about 2004. So that's my years. Over here is the average age of death. So what it looks like is the average age of death is going up a little. It's still going up. It's not going up as much for them years, but it's still going up. And then it goes up and up again. So see, this one sort of started about middle of the line and it barely went up above the line. So it barely was going uphill, but it did go uphill. So we had to pick one of these. And if you remember on the test, the function shows a steadily increasing average age of death between 80 and 2004. So if it's always going uphill, it's always increasing, okay? All right, so it looks like the ending of this is really like that test y'all just about to take. Write an equation and then answer the question. So if you can get the equation part right, then you'll get this part right. There's only one right equation over here, okay? So the cost of renting a car. So renting is going to equal, or flat rate of $45. Plus, that means put a plus sign down there. And then an additional 0.14 cents per mile. So that means you take that 0.14 and multiply by the number of miles. And y'all look over here, only one of these is right. So that one's got the multiplying the miles by the flat rate, that's wrong. That was subtracting, wrong, subtracting, wrong. So look here, 45 plus 0.014 times our miles. So no matter what, we know it's D. And I'll show you how to verify that by getting this answer. This one says, how far can you drive for $86? So you start out with your $86. That's going to equal to 45 flat rate, plus you're going to pay 14 cents per mile driven. So out of that 86, we got to take off this 45 from both sides. Because you had 86, you're giving them 45 for that flat rate, okay? So let's see what that gives us. That gives us 41 equal to our 0.14 miles. So if you got $41 and it's going to cost you 14 cents per mile, well, the way that you find out how many miles you're going is you divide both sides of this by the 0.14. Okay, you take your total money divided by how much it costs per mile. So we're going to come over here and go 41 divided by 0.14. That's giving me, what's that, 292 point, I'll round that to an 86. So I'm just gonna round it to the nearest cent here, but they might want something else on that answer. Oh, so they rounded it to the nearest dollar, so 292.86 would round up to 293. So that verifies for sure that we got a right equation. But then this is some of the function stuff. In the following situation, state whether two variables are related in a way that might be described by a function. If so, identify the independent and dependent. So the dependent's always going to be the one that depends on that other variable, okay? So you're taking a road trip. Oh, this is just like that test question you just had. You're taking a road trip in a car and want to know how far you traveled at various times during your trip. Well, how far you traveled, that's your dependent, because how far you traveled depends on what time you're looking at. So the time is your independent. So if I want to look at 1 hour, 1 hour I traveled so far on my odometer. Then I wait, then I look at 2 hours. At 2 hours, I look at my odometer. So the odometer always depends on that time. And y'all, here's the thing. Time, almost 100% is the independent variable, okay? So that put me with independent variable time, dependent variable distance. So A and B done. So this one's similar, but we don't have to identify which one's independent, dependent. They just want us to see what relationship they can have. So the volume of a gas tank, so that's how much gas can it hold, and then the cost to fill it. So technically, this would be your independent. This would be your dependent. So your answer has to go in order that they're going. So the volume of the gas tank. So the more gas you can put into a gas tank, then that means you're using more gas. So the cost to fill that tank is also going to increase. So this one says as the volume increases, the cost decreases. Wrong. This one's got the cost first. Wrong. As the volume of gas increases, the cost to fill it increases. True. And then this one has the cost to fill it increases. The volume, and that's in the wrong order. Remember, they got to go in the order that they're sort of giving them to you up here. If this is your independent and your dependent, because remember, this is like an ordered pair inside those parentheses, and that's like your X and your Y variable. Okay. So notice how they're putting them in these parentheses here. That's why your answer's got to be in the same order as they're giving those. Okay. All righty, y'all. Let's see. 51. Oh my God, this was another test question off of chapter 8 and 9 test. So if you haven't taken 8 and 9 test yet, this should really be giving you more practice with those questions, okay? So this one, in the month of January, the depth of snow resort decreases by 2 inches per day. So on December 31st, there was a depth of 65 inches. Find an equation and then pick the graph. So if you get the equation right, you'll get the right answer right here. So the depth of that snow is going to equal the starting amount, 65 inches. It's decreasing, so we're going to subtract 2 inches per day times our number of days. So let's see, they're saying January 28th. So January 28th is 28 days from December 31st. So I'm going to have 65 minus 2 times that 28. So y'all, let's figure that out. We should get one of them 4 answers up there. So 65 minus 2 times 28. So I'm using parentheses here for my multiplication, okay? So that equals 9. So let's look over here, and C has 9, so we're going to click that. Now this is just a graphical. So they're saying if this was 32 days, looks like they're going by twos. This would be 30, 28 would be about right there. So if these are going by, looks like 5s over here, that'll be almost 10, which would be 9. So all you got to worry about is get this right number using that equation, okay? All right, so it looks like the last one on this, and then I'll sort of go through some of the ones in the beginning again. So the following situation can be modeled by a linear function. Write an equation and use it to answer the questions. So be sure we identify the independent and dependent variables. So they're saying the price of a car is 19,000 today and rises with time at a constant rate of 870 per year. How much will this car cost in 3.5 years? So we're going to figure out this and then come up with that answer there. So first they say, select the choice below. So the independent variable is time. Because remember, I told you time was always going to be your independent. Yeah, so I'll have this lesson on video too, someone was asking. Time is always going to be independent, and the dependent variable is going to be, what are we looking at up here? Our price, okay? So now, so this one's backwards, so it's got to be A. The independent variable is time in years, and the dependent variable is price in dollars. The linear function that models this, well, we're starting with 19,000, so we put our 19,000. Where'd it go? It rises, so since it's rising, we're going to add 870 per year times our number of years, but we don't know, so we're just going to call that times T, which represents time. So depending on the number of years, I would multiply that by the 870, add that answer to 1900, and that would give me the value. So they're asking us to use this formula at 3.5 years. So y'all, we come down here, 1900 plus 870 a year times 3.5 years. All right, so here we go, 19,000 plus 870 times 3.5 years gives us $22,045. So we would come over here and put that in for this part. So is the linear model reasonable for this situation? Well, in the real world, I'd have probably said no, because we don't never see cars that would, in the real world, increase, right? When you get a car, it's probably going to start decreasing. So on that one, I just said A, it's most likely not reasonable, because it is unlikely that the price of a new car of the same model will increase at a constant rate. All right, so I'm just going to go through some of the beginning ones now, just to use a little bit more of my time. I'm trying to keep y'all to at least 7. And what I don't finish on this one, I sent a video this morning doing this first half of it. So you definitely got that to study with, okay? So identify the fallacy. Woo, those were way back. Each of my brother's 3 dogs has fleas. Therefore, all dogs have fleas. So you're making an assumption based on your brother's dogs. we would call that hasty generalization. Okay, circular reasoning was saying the same thing over. False cause was something like, I ate a burger at McDonald's and 5 minutes later I got a headache. Therefore, the burger gave me a headache. That would be false cause. And then straw man was like the candidates going at each other. Okay. All right. Same thing here. A television commercial shows two people who fall in love while wearing a certain brand of blue jeans. Well, the key word there was the love, right? That would be just like the ones where I gave you examples of the Michelin tires. They put a little baby in their tires on their commercial. And then they tell you, well, because so much is riding on your tires, they're appealing to your emotions. Okay. All right. Then you had to do some conversions. So we're going to convert 9 feet to inches. So the conversion I need for inches and feet is that 1 foot equals 12 inches. So we're starting with 9 feet. Now I got to cancel the feet out and turn it into inches. So since feet's on top, when I use my conversion, I got to put the feet to the bottom and the inches to the top. That way these feet cancel and I'm only left with my inches. So let's see, 9 times 12 is going to give us 108 inches. So over here, we put our 108 and then move it on. Number 4, commuter train travels 54 miles in 43 minutes. Convert that to miles per hour. So it's already in miles. What we got to do is turn these minutes into hours. So what's that conversion? 1 hour is going to give us 60 minutes. So we start with what they gave us, 54 miles in 43 minutes. Okay, so you want to write it sort of like speed, miles per hour. The miles go on top, hours go to the bottom. And that's what they're wanting me to convert this into. But right now I'm in miles per minute. So since my conversion is 1 hour is 60 minutes, since the minutes is on top, on the bottom here, I got to write my 60 minutes to the top and my 1 hour to the bottom. That way, since there's a minute on top, a minute on bottom, they cancel out now. And my final answer will be in miles per hour now. So anything on top, you multiply, then you divide by all the stuff on the bottom. So we would multiply that 54 times 60. That gives me 3,240. Divide that by the bottom, which was 43. And y'all, that gives me 75.3. I'm going to make that a 5. Just rounding off that 4 with that 8 behind it. But let me see how they want my answer. So they want me to round to the nearest 10th. So the nearest 10th is only 1 decimal place. So since that's a 5, it's going to kick that 4 up into, a 3 into a 4. So we get 75. Oh, hold on. Let me go back. I had 75.3488. So let me go back to the original because I was rounding to the nearest cents here. Now I'm going to go back and we're going to round that 3 off. But behind the 3 ain't really a 5. It was what? A 4. So that means I don't do nothing with the 3 and I keep it 75.3. And then that would be miles per hour. Well, I guess that's one reason you might not want to round off to what you think it is until you get to what they want you to do, okay? Because that would have thrown me off by 1/10, and that would have probably marked me wrong on that math app. You know how picky that thing is. All right, let me pull that down just a little bit so y'all can see this next one. Oh, carry out the conversion. They're telling me 8 ounces in a cup, 4 cups in a quart, 4 quarts in a gallon. Using a chain of these conversions, convert 7 gallons into ounces. So we're starting with 7 gallons. And we're going to turn gallons into ounces. So my conversions don't go from gallons to ounces, but they go from gallons to quarts. Now, since I got to cancel gallons, it's going to the bottom. The 4 quarts go to the top. That way the gallons cancel. Now, I don't have a conversion for quarts to ounces yet, but I can go from quarts to cups. So since I'm canceling quarts now, for every 1 quart, there are 4 cups. So my quarts now cancel. Now, I just got to go from cups to ounces. And this conversion tells me that for every 1 cup, I get 8 ounces. So now my cups cancel. So remember, they got to be one on top, one on bottom for those to cancel. All these numbers are on top. So multiply all them numbers and that'll give us our ounces. So y'all, here we go. We got 7 times 4 times 4 times 8. That gives me 896 ounces. So that one didn't even end in a decimal, so we're good. So let's see, 896 would be our B. So let me do this number 12 to give y'all one more practice on 12 and maybe 13. So let me do these. These were those ones with the interest, using the compound interest formula. So I wanted y'all to see that one. So 12 compound interest formula is A, which is in the amount after so many years, equals your principal times parentheses 1 plus APR divided by N, close parentheses, and then the exponent is N times Y, which is your number of years. So P is the principal, N is the number of compounds, APR is the annual percentage rate, the Y is the time in years. So look, they're giving me 5,000 is going to be my P. They're telling me APR is 8%. We need to turn that into a decimal by moving it left twice. So if you move left twice, you get a 0.08. Monthly compounding, that's my N. So monthly means that's 12 times a year. And then they're giving me 2 years for my Y. So now let's just replace everything. So A is going to equal P, which was 5,000, parentheses, 1 plus APR, which we made 0.08, divided by our N, we said was 12, close parentheses, and then your exponent is 12 times the number of years, which was 2. And y'all, I usually punch that one all at once on my calculator. So watch this. 5,000 times parentheses 1 plus 0.08 divided by that 12. Those parentheses. This upside down V, we call that a caret. You hit that for those exponents. And it makes the little box above the parentheses. And that was 12 times 2 for that one. Now I hit enter, I get 5864.4396 6. I'll just carry it out a little bit depending on what they want. All right, so 5864. Also, we don't have to worry about rounding it because they gave me an answer with the rounded answer. They went to the nearest cents. So that 3 become a 4 because of that 9. So we would go with C. Okay. A lot of these will be like multiple choice. So you don't have to guess as much on the rounding. All right, y'all, let's try this one. I wanted y'all to see this one because it's using the same formula, but it's solving it for another part of it. So it's rewritten just a little different. So this one says, I want to have $50,000 in a college fund in 10 years. So that would be your ending amount. In 10 years is my Y. How much would I have to deposit in an account? APR is 4.4. So if we move the decimal left, that's going to be a 0.044. Quarterly compounded means our N equals 4 because there's 4 quarters in a year. So when you're practicing this study guide, the formula that I'm giving you now will be used for this one and this number 14. So you're wanting to see how much you start with. So you're wanting to find your principal this time. Remember, your ending amount is your A. So this formula was P equals A divided by 1 plus the APR divided by N, all raised to the N times Y exponent. So y'all, it's this formula rewritten around, okay? So we got everything. Our ending amount was 50,000 divided by 1 plus, well, our APR was 0.044 divided by N, which was 4. And then our exponent is 4 times, what was my number of years, which was 10. So once we punch that in, we better get one of these 4 numbers. Now, you want to end with 50,000. So that means this has to be less than 50,000, okay? And guess what? They all are. Well, they're all sort of close. So let's see which one it is. So here we go. 50,000 divided by parentheses 1 plus 0.044 divided by N, which is 4. Exponent is 4 times 10. So they was rounding to the nearest cents. So I'm going to get $32,279. So that 7's got a 5. So that 7's going to turn into an 8. So let's see, 32279. But there's only one with 32279. So that would be C. Okay. So y'all, this one would be the same way. Let me show you how you would set this one up. I'm not going to solve it because I'm over my 7 now. But on this one, you want to have 5,000. So that'd be your ending amount. That'd be your A. 2 years on a condo. That'd be your Y for 2 years. Annual compounding. So if it's annual, that means once a year. And then your APR 5%, that would be 0.05. Move that left twice. So when you set it up, your P is going to equal your A, which is 5,000, divided by parentheses 1 plus my APR, which was 0.05, divided by my annual compounding, which is 1. All raised to the 1 times 2 for 2 years. Okay. So you would push that in and you get one of them answers real quick. So let me show you this last formula because simple interest formula, A equals P times parentheses 1 plus the APR times Y, which is the number of years. So it's similar, but simple interest don't have those compoundings, those ends. So you invest 1,000 times 1 plus APR is 3%. So 3%, move that left twice. That's going to be a 0.03 times the number of years, which is 4. So let's punch that in. So we got 1,000 times parentheses 1 plus 0.03 times 4. Those are my parentheses. So when we hit enter, we're going to get 1,120. Let me see what I did something here. Oh, okay. So I see what they're saying. This is how much is in my account at the end of 1 year. So notice what they want. They want to know, calculate the amount of interest we made. So at the end of 2 years, my account is worth 1,120. Subtract your starting amount, which was 1,000. And that'll give us how much money we made on interest. So y'all, 1,120 minus 1,000 means we made $120 worth of interest in our account. So that would be B on that. Oh, okay. So y'all, here's the thing. I sent a video this morning. Use that for the rest of this part 1. And then the one I'm going to send in a little bit that we just did in your class will be the part 2 video, okay? And it sort of picks up, when we started, it picked up where we left off on that one. So go through this, do your study guide online as many times as it takes you to get good for my final. If you got any questions, email me and I'll figure out a way. We might can Zoom or something. Get y'all fixed on that, okay? So y'all do good on this test. So the final exam, like I said, opens up on December 8th and is due by December 12th, which is not this Sunday, but the next. All right, y'all got any questions? So really, you just got to, for this week, just worry about that chapter 8 and 9 test due by Sunday, and then the rest of the time, focus on that final, okay? Also, if you haven't got me them projects of any kind or whatever, you need to send me that. Okay, there you go. So yeah, try to send it this week if at all possible, okay? All right, y'all, I'm going to end my recording.